So for load-bearing walls, you use the top number. For non-load-bearing, you use the bottom one. And then we have integrity, the middle number. This refers to not developing cracks or openings through which flames or hot gases could pass within 90 minutes. Will the wall stay, suitably, its integrity will remain so you're not getting sheets of flame like some sort of disaster movie shooting through this thing. Obviously that's a bad thing, because what I said earlier on about the lacrosse fire, it basically did its job, the people got out. If all this stuff we're talking about is really to maintain life by allowing people time to get out and for the fire people to get in and rescue. Obviously, if a building starts to collapse within 20 minutes, then that's not good, obviously. And this is about integrity. Cracks opening through which flames and hot gases can pass. Right. And then the final number is insulation, but not in a good way. Insulation here refers to the temperature of the cold surface of the system will not exceed the temperature requirements of the test within the 90 minutes. So those three numbers, and I forget where it is, but in the BCA there's a thing that will give you, a table which will give you the numbers you are looking for. And our friends at GIPROC, in their lovely red book, have things like this, which is showing a wall, which gives you 90, 90, 90, but from the outside only. They usually have from either direction. Spoiler alert, it usually is adding things like fire check. And it shows you the CSR number. Hopefully you're all aware that there's a new red book came out a while ago, and there's now 4 digits for the CSR number, not 3. So we've got millions of new systems. So anybody needs that, I'm sure we can get you an electronic copy. Hard copies are like rocking horse, you know what. It's very, very rare. And then in here you've got all the standard system things with the acoustics. Now this example I've used is not the one I would have used, because here's one I like to talk about, which is that wall. Let's say we had a wall that was a partition wall, fire check on both sides, giving you a 60, 60, 60, great. The insulation doesn't affect the FRL. The insulation affects, say in this case, the acoustic performance. But what this table will tell you is that if there's no insulation, if there's glass wall insulation of various types, or there's polyester insulation, then the FRL is not affected. But if that wall is between my unit and your unit, it's a common wall. We're going to talk about this, but that needs to be non-combustible. Glass wall that we just talked about is non-combustible. The polyester is not. So if you're doing a class 2 building, we just have to be careful that if you're doing walls that's not masonry, between sole occupancy units that we're using, yes, you might meet the FRL, tick. But if you've also got to be non-combustible, you've got to tick that box as well. And this is why it gets tricky. This is why what are we talking about exactly? Oh dear. BCA specification C1.1, I think that's on the test. I'll pause while you write that down. BCA specification C.1 defines 3 types of fire-resisting construction, A, B, and C. It's largely independent of building class, but we then go on to say, BCA Part 1, C1 tells you how to determine the fire-resisting construction for each building class. So depending on what building is used for, the building class and various other things, it will give you your FRLs that are required, but it'll also give you the type of construction that's required. So what we've got is 2 units, 3 transitory, living, residential, hotels, motels, hostels, that sort of thing. 9 schools, medical, aged care. So if you can sleep in it or be educated in it, I suppose. Once you get 2 floors or above, you're A or B. So a lot of single-storey schools, great. Single-storey aged care, fine. But once you get to 2 floors, A or B. And then 5, 6, 7, 8, which is, sounds like I'm going to start a dance routine, but I'm not. 5, 6, 7, 8 is more, no? Never mind. 5, 6, 7, 8 is more about the commercial, so obviously we're on level 32, so this would be type A construction. It's 3 floors or above, so for shops, for offices, industrial, that sort of thing, 3 floors or above. Why is that important? Because for external walls and common walls and stuff to do with lift pits, there must be non-combustible construction. External and common walls for type A and B construction. Now that's been in the BCA for a very long time, certainly 2009. That's the oldest one I could get my hands on. And what that means, non-combustible means applied to a material not deemed combustible as determined by 1530 Part 1, which back to my mate there, the question about whether that test is suitable, because you can't use it for this, and yet it falls between the cracks, as it were, because of the way the regulations are written. So applied to a material as per that test, or applied to a construction or part of a building constructed wholly of material that are deemed to be non-combustible. So in other words, cut to the chase, all insulation and sarking products installed on an external wall or common wall must be non-combustible. About a year ago, BCA 2016 Amendment 1 came out, in March I think. And before that came out, I was running around, not that I do a lot of running as you can tell, but I was slowly walking around telling people, don't worry about this sarking thing, it's all going to change when this amendment comes out. Don't worry, it'll be fine, I said, because the amendment public comment had said, sarking type membranes, Samuelty index less than or equal to 5, that's all you've got to worry about. Cool, we all said. Because it makes it a bit easier, we can talk about building science rather than non-combustibility and then building science. Unfortunately, when push came to shove, when the amendment came out, they dropped that bit from the public comment. So that's why that was important. So that's why all products, including insulation and including sarking, non-combustible is the default position. But sarkings aren't tested to 1530 Part 1, I hear you cry. That is true. That is very true. So, there's no concession to sarking products from non-combustibility requirements. Okay? Sarking products are currently assessed under BCA Part 9 as bonded laminate materials, which basically says non-combustible stuck together with less than 1 millimetre of adhesive. That's the short version. So the only sarking products currently available on the market that meet BCA C19 are not vapor permeable. So we have a product which is called Fire Spec. It's a white woven glass fabric, which on its own has been 1530 Part 1 tested. Layers to give it 50 mil thick, 1530 Part 1, no problem. The other side, the shiny side, is a single piece of aluminium, very thin, but aluminium. Aluminium does not burn below 750 degrees C, is deemed to be non-combustible, and the two stuck together, less than 1 millimetre of adhesive, meet BCA C1.9. That's what we have, and there's another one out there that's basically, you couldn't pick them out of a lineup. They look the same. So there's two membranes that are suitable for deemed to satisfy construction when non-combustible construction is required. We shouldn't ever call them a non-combustible sarking, because, as my friends pointed out there, we've already talked about that, perhaps not sufficiently, but you can't use that test. So that's what's available, but it then opens up the building science argument, issue, problem. BCA requirements versus condensation risk. Two elements can conflict with each other. External wall build-up with non-combustible insulation and sarking meets the BCA deemed to satisfy requirements, but it may increase the condensation risk. Now, in Brisbane, it's not as big an issue. If we were all in Melbourne, you'd be wearing a lot more black and probably those round sweater things they all like down there. A few more hipster beards, perhaps. I'd be better dressed, certainly. So that's fine. That's fine. But down there, where it gets proper cold, and they have much bigger issues with condensation because of the cold than we do, this has been a major problem. So this is DTS we're talking about. But alternative solutions, we have our wonderful vapor permeable EnviroSeal tiny pores membrane that lets the vapor through but doesn't let liquid water through. If you were here a year ago, that's what I spoke about. Not exclusively, it was condensation membranes, etc. in great depth. Well, we've got that. Not non-combustible. Aren't tested for non-combustibility. Not non-combustible. So this is where we have the whole fun and games with certifiers, because we have a fire engineer's opinion that says you can use it in 25 pages. It's obviously shortening it. You can use it. There are 4 membranes on there, but it's whether the certifiers will accept it. This has been the whole, if you want deemed to satisfy, we've got one, but it's not necessarily the best building science solution. Less of an issue for us in Brisbane than, say, Sydney or Melbourne, or Hobart, something like that, much worse. Or even Cairns, where it's the opposite, it's the vapour barrier we're looking for. But it does add a level of complexity, which I'm hoping is going to go away soon. So, as it says in here, compromise may be needed. So we have to discuss the engineer with our fire engineers, our ESD consultants, and our material supplier and certifiers. I don't know why I've missed certifiers out. They're very important. We've got to discuss it with the certifier, the fire engineer, the ESD consultant, and the material supplier to work out the best option. It's like playing Twister, I suppose, while someone's shooting at you, maybe. It's quite a tricky. Any Star Trek fans in? It's like the Kobayashi Maru, no? I've got to give up on that joke because I've done it about half a dozen times and nobody knows it. Anyway, moving on. AS5637 Part 1 BCA Specification C110.